LTC1540 Ultra-Low Power Comparator, Linear Technology. Welcome to this training module on Linear Technology's LTC1540 Ultra-Low Power Comparator. This training module introduces the basic operations of the LTC1540 and its typical applications. The LTC1540 is an ultra-low power single comparator with built-in reference. The comparator's features include less than 0.6 microamp supply current over the commercial temperature range, a 1.182 volt plus or minus 2% reference, programmable hysteresis, and TTL CMOS outputs that sync and source current. The reference outputs can drive a bypass capacitor of up to 0.01 microfarad without oscillation. The comparator operates from a single 2 to 11 volt supply or a dual plus or minus 1 volt to plus or minus 5.5 volt supply. Comparator hysteresis is easily programmed by using two resistors and the Hist pin. The comparator's input operates from the negative supply to within 1.3 volts of the supply voltage. The comparator output stage can continuously source up to 40 milliamps. By eliminating the cross-conducting current that normally occur when the comparator changes logic states, power supply glitches are eliminated. Here is the pinout and a functional description of each pin. The comparator operates from a single 2 volt to 11 volt supply. The LTC1540 includes a separate ground for the comparator output stage, allowing a split supply ranging from plus or minus 1 volts to plus or minus 5.5 volts. Connecting V to ground will allow a single supply operation. If the comparator output is required to source more than 1 milliamp, or the supply source impedance is high, V plus should be bypassed with a 0.1 microfarad capacitor. The comparator inputs can swing from the negative supply V minus to within 1.3 volts max of the positive supply V plus. The inputs can be forced 300 millivolts below V minus or above V plus without damage, and the typical input leakage current is only 10 plus or minus 10 picoamps. The comparator output swings between ground and V plus to assure TTL compatibility with a split supply. The output is capable of sourcing up to 40 milliamps and sinking up to 5 milliamps while still maintaining nanoampere quiescent currents. The output stage does not generate crowbar switching currents during transitions, which helps minimize parasitic feedback through the supply pins. The internal band gap reference has a voltage of 1.182 volts referenced to V minus. The reference accuracy is plus or minus 2% from 0 degrees C to 70 degrees C. It can source up to 1 milliamp and sink up to 10 microamp with a 5 volt supply. The reference can drive a bypass capacitor of up to 0.01 microfarad without oscillation, and by inserting a series resistor, capacitance values up to 10 microfarads can be used. Bypassing the reference can help prevent false tripping of the comparators by preventing glitches on V plus or reference load transients from disturbing the reference output voltage. Hysteresis can be added to the LTC1540 by connecting a resistor between ref and the Hist pins and a second resistor from Hist to V minus. If hysteresis is not wanted, the Hist pin should be shorted to ref. The difference between the upper and lower threshold voltages, or hysteresis voltage band, is equal to twice the voltage difference between the ref and Hist pins. When more hysteresis is added, the upper threshold increases the same amount as the low threshold decreases. The LTC1540 is ideal for use as a nanopower level detector as shown in the figure. R1 and R2 form a voltage divider from Vin to the non-inverting comparator input. R3 and R4 set the hysteresis voltage, and R5 and C1 bypass the reference output. The LTC1540 can be connected as a micropower low dropout linear regulator as shown in the figure. When the output is low, Q1 turns on, allowing current to charge output capacitor C1. Local feedback formed by R4, Q1, and Q2 creates a constant current source from the 5-volt input to C1. R4, R1, and Q2's VBE also provide current limiting in the case of an output short circuit to ground. C2 reduces output ripple, while the R2, R3 feedback voltage divider establishes the output voltage. The figure shows a circuit for a 30 milliamp power supply that has a timed auto power off function. The comparator output is the switched power supply output. With a 10 milliamp load, it typically provides a voltage of VBAT minus 0.17 volts. The whole circuit draws a mere 0.8 microamp of quiescent current with VBAT equal 5 volts. The 3-resistor voltage divider programs 50 millivolt of hysteresis for the comparator and sets the N- voltage at 200 millivolts. This gives an N plus trip threshold of approximately 150 millivolts. The battery shows how to use the LTC1540 for a low battery detect, drawing only 1.4 microamp at VBAT equal 2 volts. The circuit is powered by a 2-cell NiCad battery. The VBAT pin could be as low as 1.6 volts when the batteries are completely depleted. The electrical specifications of the LTC1540 guarantee operation down to a supply voltage of 2 volts, but it is still functional with the supply as low as 1.6 volts. Some parameters, such as Vref and VOS, will be degraded on lower supply voltages. The input voltage range extends from 0.9 volts below the positive supply to the negative supply.